Hi everyone, my name is Nikhil and today I'll be presenting a paper titled Retrieval Enhanced Transformer published at Newer IPS 2021 by James Ainsley and colleagues. I chose this paper because it directly connects to our project on building a smart chatbot with a diet planner, movie recommender, and PDF-based Q&A. One of the biggest challenges in modern chatbots is factual accuracy. Most transformers like GPT generates responses based purely on what they have memorized during training, but they don't have access to external knowledge at runtime. This paper proposes Retro, a model that retrieves real-world information on the fly to generate better, more accurate responses. It aims to improve not just accuracy but also memory efficiency and interpretability in language models. Here's how retro works. Instead of relying on the internal model weights, it adds a nearest neighbor retrieval step. A huge database of token chunks is indexed using embeddings, kind of like how we use FAISS in our project. When the model receives input, it retrieves the top relevant chunks and combines them with the input tokens. The enriched context is the fed into the transformer, helping it generate more informed responses. Retro uses a two-step training process. First, it's pre-trained with Retrieval incorporated, then it's fine-tuned for specific tasks. The system retrieves from a database of 2 billion tokens and uses cross-attention to blend the retrieved data with the original input. What's really cool is the Retro achieves similar performance to GPT-3, but with much fewer parameters, thanks to this retrieval strategy. On multiple benchmarks like question answering and language modeling, Retro performs really well. In fact, their 7.5 billion parameter model matches the performance of GPT-3, which has 178 billion parameters. So it's not just about accuracy, but it's also more efficient and interpretable because we can see which documents the model retrieved to answer. Here are some key strengths. It's more scalable and factually accurate. You can see the retrieved chunks, so it's more transparent than black box models. On the flip side, it needs a huge external database. The retrieval database must be well aligned with your use case, and the system complexity increases. Combining training with retrieval isn't simple. This paper is super relevant to our chatbot. In our PDF and Q&A module, we use PyPDF loader and FAISS to create a chunked vector store, which is basically what Retro does. Their retrieval enhanced architecture inspired us to use sentence transformers for chunked search. We use similar logic in both our movie recommendation and PDF answering modules, routing queries and pulling in relevant text chunks. My biggest takeaway was you don't need bigger models, you need smarter architectures. Retro uses how retrieval plus generation can beat massive models like GPT-3, especially when factual correctness matters. It also got me thinking about modular chatbot design, like plugging in retrieval blocks for specific domains. My main critic, Retro, is not lightweight. It needs big infrastructure to run. So deploying something like it in a small project might be tough. Thanks for listening. This paper really validated many of the design decisions we made in our chatbot project, especially around the PDF Q&A. If you are interested in more efficient, fact-aware chatbots, Retro is a great model to explore.